What's up, guys? Swirsky here. Right away, if you don't have something to write with and write on and some type of way to use a calculator, you need to pause the video and make sure you have that all set up. So I'm going to wait 2 seconds. 1, 2, pause the video. Okay. Just before we get moving, just so you can be a part of, we got a few examples and stuff like that. So let's make sure that we're all set with that. Otherwise, our assumptions right now before we get going is you understand the basic properties of exponents up to here, okay? That means that when I look at something like this, I can be pretty confident in solving it. Okay, if you're not, I have some resources for you in the I Need Help tab in your student resource. Okay, so please make sure that you're on top of that. But other than that, our assumption is that we can do things like that up to this point. So here's the two that we're talking about. Power property of equality, and the big one is the common base property. Power property, this one, all that it's saying is that if A equals B, so let's just use a really easy one, 10 equals 10, that's obvious, that if I raise it to any power, it's going to stay the same. So 10 to the second is still going to be the same as 10 to the second, okay? It can obviously get more complex than that, but that's the basics for it. The other one is the common base property of equality. This one is just saying that if I have a common base, so let's just call it, let's call our common base 2, and say this is x, 2, and let's just square it, make it as basic as we can. If the bases are the same, then the exponents are going to be equivalent because we have an equivalent expression or an equivalent equation to begin with. So that would mean that I can say x has to equal 2. Now, obviously that's pretty basic, and we can make this a little bit more complex. So let's do that. So let's call this 2. And let's make it like 3x minus 4, why not, equals 2, and let's just call this to the 20th. Okay, so since the bases are the same, I know that my exponents are equivalent as well. So I can set them equal to each other. 3x minus 4 equals 20. So I can figure out what that x value is. Go through the process, 3x, add 4, 24, x equals 8. Okay, again, not too complex, not too crazy. Here's where we can start getting a little more complex. And the question you can ask is you can say, what if the bases aren't initially the same, like letter A here? So if I have like this one, 8x equals 4. I don't initially have anything that I can do, but I can turn them into equivalent bases by turning them into coefficients with exponents in them. So meaning, you see 4, you can also see it as 2 squared. It's just another way to write that. Same thing with the 8. The 8 can be written as 2 to the 3rd. Still with x. Okay, now I have the same base. Okay, and I can actually rewrite the 2/3 to the x a little bit easier, 2/3 x. Okay, so now that I have equivalent bases, I know that I have equivalent exponents. So I can set that equal. 3x equals 2. X has to equal 2/3. Okay, the x value is at this point kind of arbitrary just because it can be whatever. It just depends how we set it up. Okay, so why don't you do this with your scratch paper? Why don't you go ahead and give B a shot, pause the video, see if you get it, and then we'll come back and solve that one. Okay, let me finish my erasing. So if I do that, 27x over 81. Hopefully you saw that I got a base of 3. 3 to the 3rd, and I'll just put it all in there. And then I have 1, and then this is 3 to the 4th. So the bases are there. Now I just got to make it look equivalent. So leaving this as a fraction isn't going to help, but I can move that by making this a negative exponent. Now the bases are all here, and now I have equivalent exponents. 3x equals negative 4, x equals negative 4/3. Okay? So you can see we can get a little bit, we can start getting pretty complex with that. So let's try and add to the trickery, because we're going to see what you can do with your properties and how you can manipulate your equations to get the same base. So try it again with C. I'll erase this and then pause the video, see what you can get, and then we will come back and solve that. All right. So hopefully you saw that I got a base of, this would be 7 squared, 3 squared, which is nice. All that to the x. And then 3/7. Here's the problem, obviously, is that the bases are flip-flop, so they're not quite the same. But I can make them the same. How can I do that? This one I can flip to make 7/3 by simply doing a negative exponent. If I take 3/7 to the negative and do a -1, that's the same thing as, right? Can we say that 7/3 to the -1 is the same as 3/7? Yes, we can. Okay, so now I have the same base. But now I just have to apply the pieces that I have here. So 3/7 to the -1 to the 3/2, that would change this whole thing to 7/3 to the -3/2. Okay, and then for this one, I can basically factor out that exponent of 2 and change that to 7/3 to the 2x. So I should only have the base, and then what I have remaining are my equivalent exponents that I can set up. So that's what I'll do. I'll go 2x equals -3/2. Hopefully your fraction stuff is good. Instead of dividing by 2, I can multiply by 1/2. So then this becomes -3/4. Okay? Again, you can make them pretty complex. So just pay attention to, if I don't have the same base, I can turn them into the same base to be able to solve those, to be able to figure out what that exponent has to be. Okay? Last little chunk is rational exponents. Rational exponents you've seen before. We've just seen them as roots. Okay? Square roots. We usually don't put that 2 out there, but that's why it's called a square root, because this is equivalent to a rational exponent, x to the 1/2. Okay? So that's the same thing. Same thing if I had a cubed root. Well, that's just the same thing as saying x to the 1/3. Okay? Well, what if I had something where it was x to the 5/3? Well, I'm still moving this, okay, as the root. And then the numerator would just stay as the power inside. Okay? So it doesn't matter. Hopefully that kind of generality makes sense, where it doesn't matter what the two rational exponents are or the values are. We can just manipulate. Okay? But here's where it comes in to help us. Is that if I look at things like this, so if I have x to the 4th equals 3,000, I want to know what x is. Okay, now it obviously would be a little easier if this was a square, but because it isn't, I can look at this as simply just taking the rational exponent to be able to find it. So if I took, this is x to the 4th, if I just took 3,000 to the 1/4, I can figure out what x is, right? I'm balancing this equation. So I'm taking it to the 1/4, 1/4. Okay? Now I can just simply do that on my calculator. Wait, jump this. I'm hoping that this this might be sideways, so I apologize about that. But you can see, I can just simply take 3,000, and that the caret above the division sign on that right-hand side, that gives you to the power of. And then I just simply go 1/4, and I get right around 7.4. And rounding in this case is fine. We're just getting an approximation. So x is going to be just about 7.4. Okay? Basic enough. Why don't you go ahead and try the last one here, so part B. Okay? See what you get. Okay? All right. Last one here. So if I have 6x 2.5 equals 90. And so we should get, sorry about that, guys, my kids are running around. X 2.5, I got to divide by 6, so that's the same thing as 15. Again, if I want to find out what x is, I can simply just take 15 to the 1 and 2.5. And I can do that on my calculator. If I just take 15, see if I can remember this, to the power of 1 divided by 2.5, rounded to where it makes sense. 2.95 is just about fine. And so x would equal 2.95-ish, so we'll say about, okay? So that's what we're going to focus on is the rational exponents and also being able to do the common base properties with that, okay? So that's what your practice will be focused on. Again, if you need other stuff, check that I Need Help tab in your resource page. Otherwise, have a great day.